from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about little tiny space bugs of doom. And if we have time, glaciers on Mercury. Who asked for that? And of course, taking listener questions about all things in the universe. We record the show every Thursday at 4 p.m. Eastern. So call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about science as a philosophy. But first, you know what's coming, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI. I gotta redo that because I'm not the chief scientist at COSI anymore. It's even scribbled out in my notes. Oh man, sorry folks. I left that job. So I put a line in it. Like, see, live streams, hey space cadets, how's it going? This is my script. And I had a little line there for no, I don't work at COSI anymore, but I gotta make that thicker. Because, I did like 60 episodes, and it's built in to say I'm the chief scientist. So I'm gonna scribble that out, give it a good old scribble. When was the last time you gave a thing something a good scribble? Feels good. It's like it doesn't even exist anymore. Marker! This is why we come over here, Greg. Say hi to the space cadets.
Hi guys.
Thank you for the mark. Oh wow, that's way more efficient.
Sharpies
are the best. This show is not brought to you by Sharpie.
So are they looking for a chief scientist at COSI? Is that what you're telling me?
Hey, if a job pops up, you're welcome to apply. Good luck with that one. Take two. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, and for the next half hour, your agent of the stars. Got an exciting show for you today on Space Radio, where we talk about all the wonderful things in our universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus. So call 888-581-0708. Light it up. You can also leave voicemails anytime. Get those calls in. You can also follow along with our live streams on YouTube and Twitch. Go to spaceradioshow.com for the links, and they are tuning in live right now from all over the world, including Salt Lake City, Utah, Atlanta, Georgia, the UK, Virginia Beach, Virginia, Kent, which is also UK, London, Ontario, Amsterdam, Sydney, and Garden Grove, California, and other places. Seriously, folks, I've only prepped 10 minutes of show material tops. Let's get those calls in. Before I start taking calls, I wanted to share some interesting bits of news I caught recently. And there's this wonderful, I hesitate to call a scientific paper cute because it somehow like demeans the hard work and sweat and labor of scientists, but it's a cute little result. It's a very interesting result. This is led by Ryan Blaustein and collaborators who are biologists, evolutionary biologists. And yes, evolutionary biologists have some interesting things to say about space. And specifically, they were looking at the International Space Station. The International Space Station, the environment in that space station is 100% human constructed and 100% human controlled. So we constantly monitor that environment, the oxygen levels, the CO2 levels, the moisture content, what food gets sent there, the recycling systems, the amount of water, everything is super duper hyper controlled in the International Space Station. And the International Space Station is full of little tiny germs because if you're a human, you're a host to like a bajillion germs. That's a real number. And you're just going to carry it with it. So you can have a 100% sterile environment. And as soon as you put someone up on that space station, it's germs everywhere. So it's all the usual mix of germs. Most of them are harmless. Some of them are harmful, but the harmful ones are pretty rare. And they have a tough time getting inside you, so you don't always get sick. And this research study was very, very interesting. They looked at a couple different species of bacteria, and what they were able to deduce was that in this, what they call a built environment, this 100% human constructed environment, that you might be tempted to think that because this environment is entirely human constructed and 100% monitored all the time and it's always the same, that maybe there'd be no reason for evolution to do its thing. Right? Evolution is driven by environmental changes or response, or some kinds of evolution are driven by environmental changes. So, of course, if the environment changes, then species will adapt and radiate and evolve and do all that wonderful biological stuff. But you might expect that in a sterile environment, a well-controlled environment, that there just won't be any evolution. But these researchers found for these two species of bacteria that they studied that, yep, they keep evolving. Even though the environment on the space station is 100% controlled and stays the same, these bacteria continue to evolve. They continue to change. Not necessarily in harmful ways, not necessarily in disastrous ways, but they simply change. Evolution don't stop for anybody, not even the International Space Station. And this is very interesting implications for long-term human habitation outside of the Earth, in space stations and asteroids on other planets. If we create artificial environments, all of our germs and bugs are coming with us, and they are going to evolve and they're going to change. We cannot assume that nature will simply stand idly by on the sidelines while we have our little space adventures. And that's the latest and greatest when it comes to space. But it's time to answer some questions. All right, great questions. I see the questions rolling in from the space cadets. Love it. We do have a voicemail, so I'm going to take the voicemail for the first block, and then we'll do some space cadet questions. Thank you again, Nancy, for already collecting all these wonderful, wonderful questions. Maybe I shouldn't drink like a highly carbonated beverage when I record shows. Greg is shaking his head because I'm burping up a storm here. And I'm not stopping either. So I guess I didn't learn my lesson. Yeah, great comment, Brian Street. The germs evolve up until they're, implanting eggs in your face. And then they evolve you. Then you're part of them. We have a voicemail lined up. Remember, you can call 888-581-0708 anytime to leave a voicemail. And here we go with the question. Greg, play the tape.
Hey, Paul. I like your show. I just started watching it on YouTube. My name is Jason, and I'm from St. Louis, Missouri. And my question is when we talk about how space and the universe is always expanding, are we talking like galaxies are spreading out further and further away from each other into the darknesses of the universe? And if so, it's just that the universe is when they say it just goes on forever, it just seems like it just goes on like the galaxies are spreading out to an empty void kind of a thing, or like what's beyond the void. I know a lot of theory goes into it, but basically when they say though that everything's spreading out, keeps spreading, is it just going to endlessly spread forever, or do they have any ideas about that? But again, if you just have any idea, I'd appreciate it. And thanks for the show. It's pretty cool to watch. Bye.
Very cool question. Thank you so much for calling in. This is such a fun question to answer because the answer really, really sucks and nobody likes it. And I get a small amount of perverse joy out of giving this answer. And the answer is we live in an expanding universe. We've known this ever since Edwin Hubble discovered it about 100 years ago. We live in an expanding universe. Our universe gets bigger every day. What does it mean for a universe to get bigger every day? Your intuition, when you imagine expanding things, like a loaf of bread in the oven expanding, like a balloon expanding, you have an image in your head of a thing that starts out small, that occupies a small amount of volume, and then pushes out. It fills out. There's like air around it, and it goes in, pushes into the air, and then the inside volume gets bigger and bigger and bigger. I want you, can you all do me a favor? When you think of the expanding universe, to totally 100% without question eliminate that visual metaphor from your mind. When a cosmologist, when someone who studies the universe says our universe is expanding, don't think of any earthly examples of things that expand, because your earthly examples will lead you astray. Turns out the universe is somewhat larger and somewhat more interesting than, you know, a loaf of bread. Don't get me wrong, loaves of bread are very interesting, but the universe is very complex. When we say that the universe expands, what we mean is that the distance between galaxies grows with time. So if I have two galaxies, and this is on average, this is statistical, blah, blah, blah. You get the idea. If I have two galaxies and I look at them in one moment of time and I break out and I freeze frame it and I break out the ruler and I measure the distance between the galaxies. Okay, I record that number. Say that number is 10. Doesn't matter what, just 10. And I wait a while. I unfreeze the universe, let the universe do its thing. I go, you know, maybe I make a sandwich, maybe a grilled cheese, maybe some pimento cheese spread. I just hang out for a bit and then freeze frame again. And I go back to those galaxies and I measure the distance between those galaxies. I break out the rulers, the measuring tape, everything. Measure it. It's not 10 anymore. It might be 11. It might be 15. It might be 276. The distance between the galaxies has grown. And I can do that with any pair of galaxies in the universe. And on average, statistically, the universe will get bigger with time. The distance between galaxies will grow. There is no edge. I'm letting that pause be as pregnant. Like that is an 8-month. This is a 3rd trimester pregnant pause right there. The universe has no edge. The universe has no center. Our universe is not expanding from anything. Our universe is not expanding into anything. There is just the universe, because if our universe were expanding into something, that would be a thing, and the universe is by definition all the things. So that would be the universe too. The universe is all there is. There is no edge. There is no center. Galaxies get further apart with time. Period. End of sentence. End of segment. Thank you so much for that wonderful, wonderful, very powerful question. Don't forget, you can call 888-581-0708 to join the conversation. You can leave a voicemail anytime. You also follow along on the live streams like the Space Cadets are doing right now over on YouTube and Twitch. Go to spaceradioshow.com for the links. And this show, which is called Space Radio and is hosted by a person named Paul Sutter, is brought to you by you. Go to patreon.com/PM Sutter to learn how you can keep this show on the air, how you can keep Greg's family fed, gas in his car, mortgage paid. He doesn't own a house. Rent paid. You can make it happen. You can't make all of Greg's dreams come true. You can make a small subset of Greg's dreams come true if you go to patreon.com/PM Sutter, and I'll see you after the break. Do you own a house or do you rent? You rent. Greg's a renter. Nothing against renters. Actually, in a lot of situations, renting is a smart move. You're a lot more mobile. You know, you're not tied down. You don't have to play that market. You don't have to worry about, like, in a few years, oh, is the bubble going to pop and I'm going to be underwater? Renting's a smart play. Renting's a smart play. I own a house, but renting's a smart play. Poor Greg. All the things. Brian Street, are there any counter theories to dark matter, dark energy? What happened to Hubble? Ooh, good question, SAHM. What happened to Hubble? Oh, and tardigrades. We can talk about tardigrades. I love it. I love Space Cadets. I just got to say, I love all your questions. I love all your questions. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more Space Cadet questions ready to go, but remember, you can join the conversation by calling 888-581-0708 or by following the live streams. Go to spaceradioshow.com for the links. And if you think I am too mean to Greg, email spaceradioshow@gmail.com. That address does not exist, so I will not get your input. But, call up the station and tell me if I'm being too mean to Greg on the air or if I'm not being mean enough. Your vote matters. Now, on to some wonderful Space Cadet questions. We've got Chemistry Guy on YouTube asking, what are your thoughts about tardigrades? Seeing as they can survive in space but not anything more, do you think they could be part of this panspermia theory? And related to that, Pure Ostension over on YouTube asked, does the famous space bear, tardigrades, whose proper name I don't know, tardigrades, have any less famous but equally interesting cousins? So here's the thing with tardigrades. If you haven't heard of tardigrades, they're these little tiny creatures. They look like sort of cute little vaguely gummy bear things, except with horrible monster mouths. So you wouldn't want to see a large-sized tardigrade. You would run away in fear. But since they're really tiny, you can call them cute. And they have this wonderful adaptation to harsh environments, where if they run into an environment that's too acidic or doesn't have enough food or not enough water, they can curl up on themselves, wrap a protective shell around themselves, and just hang out for a really, really, really long time. I think we've even irradiated them, and they're totally cool. And then once conditions improve, once you add a little drop of water, a little snack, like the aforementioned pimento cheese spread, which is a very yummy snack for all sorts of creatures, you give them the little snack, and they wake up, and they go back to being tardigrades. Now, what about tardigrades in space? Like, if you were to put a tardigrade on the side of, say, the New Horizons probe, which is currently 5 billion miles away from Earth, is the tardigrade still there? It's in stasis. Could you bring it back to Earth, warm it up, and it'd be just fine and tell you all sorts of cool tales about the Kuiper Belt and Pluto and everything? And if that is the case, is that potentially an answer to a very fundamental question, which is, hey, how did life get started on the Earth? Did life start here from the raw materials, from the primordial soup? Or did it start somewhere else and get spread here? Like seeds. This is what we call the panspermia idea, where life originated somewhere else and was spread throughout from solar system to solar system throughout the galaxy. Here's the thing about space. Yeah, tardigrades are really hardy, and they're really impressive, and they're really cute, I guess, as long as they stay small. Space is hard. Space is hard. Yes, we found microbes on the outside surfaces of some spacecraft, the International Space Station. Yes, they can survive in space or space-like environments for short periods of time. If you want to cruise from one solar system to another, if you want to be a little tardigrade and go into hibernation and go from one solar system to another, nearest, if you were to target and get lucky, the nearest neighbor solar system, you're talking a journey of 40,000 years. And that's only if you get lucky. If you just shoot yourself off into a random direction in space, first off, most likely you aren't hitting a single star ever, because there's a lot of space out there and not a lot of stars. But if you happen to come by a star, we're talking million years, 2 million years before you even get close to a star, and then you have to have the lucky chance of getting captured into an orbit and then hitting one of the planets and then seeding and surviving that re-entry event in that great cataclysm. Remember, when rocks tend to fall from the sky, they kind of blow things up. Not the friendliest environment for life. Life is very, very hardy. Greatest respect to life for sticking it out for so long. Space is hard. Space is deeply, deeply hard. Surviving in space is deeply, deeply hard. Could a tardigrade remain in stasis for 2 million years in complete and total vacuum, irradiated, constantly bombarded with cosmic rays and high-intensity radiation? I'm not going to say absolutely no, because you know what? Nature has a lot of surprises. I'm going to say I'm not betting on the water bear. I'm not betting on the tardigrade. I'm going to go for something else. Now, totally switching gears back to cosmology, because this is the next question that came up from the Space Cadets. Brian Street over on YouTube asking, are there any counter theories to dark matter and dark energy. So, if you didn't get the memo by now, here it is. Most of our universe is of a form completely unknown to physics. Somewhere around 95% of the contents of our universe are unknown. We know that they exist. We have great, solid, multiple independent lines of evidence that things like dark matter and dark energy exist, but we don't know what's going on. Dark matter, we think, is some form of matter that doesn't interact with light. You're probably swimming through a giant pool of dark matter right now, but it just doesn't talk to you. So it just swims right through you. You don't even ever interact with it. It's totally invisible, but we do see it through its gravitational interactions inside of galaxies and clusters of galaxies. Dark energy is just the name we give to the accelerated expansion of our universe. Galaxies aren't just getting further and further every day. They're getting further and further, faster and faster every day. We call that dark energy. Basically, no clue what's going on. So when we see all this stuff, when we see all these puzzling observations about the universe, we can ask ourselves, okay, nothing makes sense. What's going wrong? Are we getting physics wrong? Do we not understand gravity? I mean, Einstein's smart, general relativity is super slick and looks really complicated, but maybe it's not up to snuff. Maybe it's not up to task of being able to explain truly cosmological things. Or maybe there's more stuff in the universe. Maybe our theories of gravity are A-okay, just fine and dandy, but there's more stuff. There's stuff that we didn't know about before. Both of these ideas are totally valid. Both of these ideas have been pursued in the past with other theories and other situations and other kinds of physics and even astronomy and astrophysics and cosmology. Both have led to very successful conclusions. When it comes to dark matter and dark energy, these large components of our universe that we simply don't understand, we're down to just like one hypothesis, that dark matter is a thing, that it's a particle that doesn't interact with light. And when it comes to dark energy, we know it exists, but we don't think our theories of gravity are wrong. We don't think general relativity is wrong. Because every time we try to move away from general relativity, create an extension to it, modify it, it breaks something else. It breaks some other observation. And so the only conclusion we're left with is that, yeah, dark energy exists, dark matter exists. We do understand gravity at these scales, in these behaviors, in these modes, but we don't fully understand what the universe is made of. That's our only remaining conclusion after decades of work. What are dark matter and dark energy? Well, that's a different problem, isn't it? We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. Oh yeah. Timothy, I'll answer this question just to you guys. This isn't going on the air. This is just for you. Timothy Blahout asked, I read there's a crater full of water ice on Mars. How does the water not sublimate? If I leave ice cubes on my refrigerator too long, they disappear. Mars is very colder and dry. You're absolutely right. So what happens on Mars or on Mercury or on the moon is, you're right. If you have ice, if you just have a chunk of ice, the ice will sublimate. It will turn into a gas and it will evaporate. Unless it's really cold. If it's cold enough, then that sublimation process is very, very slow. And eventually the ice will sublimate, but if it can be replenished, it can be renewed, then the ice can stay there. And also the water ice can mix with other kinds of ices. Like the polar caps on Mars, those are mostly dry ice. Those are mostly carbon dioxide ice. And you can mix the water ice with that and they can hang out together and be very persistent. So what saves ice in the vacuum of space is the totally cold temperatures. But yeah, if you hit it with the sun, it's gone. It's gone. Raj, what do I think about the recent FRB's discovery, the Furby's discovery? Same story every time, man. Our universe is loud in the radio. There's lots of bleeps and bloops, and we don't understand a bunch of sources of them. There's some high energy ones that we don't understand, and that's it. It's an interesting astrophysics question. It's no one talking to us. It's no one talking to us. Sorry. It's the same. It's about every 6 months. There's a Furby story. Furby, by the way, FRB, fast radio burst. For those of you not clued in. What was my blue shift? Oh, science and philosophy. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get just a little bit closer to you. And today I want to talk about science as it relates to philosophy. This came up. I was at an event last night at Gramercy Books in Bexley, a wonderful, wonderful bookstore. If you haven't been there, they have a great curated selection, amazing, amazing stuff. I'm not just saying that because they invited me to come talk. It really is a very impressive bookstore. Had a great audience there, talked about my book, and like I tend to do, just threw it open for Q&A because I don't feel like doing any prep work. And so the audience had tons of questions, and a very intelligent young woman asked, what is the relation? Can science ever be thought of, as separate from philosophy? And my answer was, well, science is philosophy. Science is philosophy. I have a Ph.D. in physics. Ph.D. stands for philosophy doctor. I'm a doctor of philosophy in physics. The old name for physicist, if we were doing this radio show 200 years ago, we'd be very confused because we didn't know about the existence of radio. But if we were doing it 200 years ago, I would not be physicist Paul Sutter. I would be natural philosopher Paul Sutter. I'm a philosopher of nature. I study natural systems. I try to understand how they work. Science is a branch of philosophy that is specifically tuned, specifically designed to answer very specific questions about nature and how things work. And we have a very specific tool set, like empirical observations and the scientific method and mathematics that allow us to answer those questions very, very well. But at the end of the day, it is a form of philosophy. And it's very, very good. Science is very good at answering some kinds of questions, very, very bad at answering other kinds of questions because it is a tool, it is a branch of a much larger family of thought, a family of ways of thinking. And speaking not at all about philosophy, I do want to remind you about the All-Stars Party at the end of June. This is a long weekend outside of Joshua Tree National Park, which is about an hour and a half east of LA. Absolutely gorgeous park. So it's an Astro Tour. We're hanging out. There's going to be a bunch of us, tons of people there, tons of storytellers, tons of all-stars. Great party. Talks, panel discussions, debates, fist fights. I don't know. Again, we haven't fully set the itinerary. There might be boxing. I don't know. There's going to be cocktail receptions and food receptions. It's going to be a really good time during the day. And then every single evening, we're getting bussed out to the park to spend some serious quality stargazing time. It's going to be a great time. Go to astrotours.co. That's astrotours.co for links to the All-Star Party. Get your reservation in now. You just have to put in a deposit. Get that reservation in now so you can guarantee your spot. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you wonderful people. Visit patreon.com/pmsutter to learn how you can keep this show going. Thanks to the truly, truly amazing Greg Moebius for producing, Nancy Graziano for wrangling the Space Cadets, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join me live or leave a voicemail anytime. And you can also catch the live streams on YouTube and Twitch. Go to spaceradioshow.com for the links. And of course, thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. Hey, everyone. Thanks for watching. I know these shows are way too short. They go by in a flash. And now I can drink my heartily carbonated beverage and belch to my heart's content because we're not recording. Greg will edit that out anyway, right? It'll only be between you and me. No, he's gonna leave it in because I said mean things about him. If you haven't bought my book's been sitting here. I meant to plug my book. If you haven't bought my book yet, go to pmsutter.com/book. You can order autographed copies off my website. Isn't that cool? Promo?
Promo.
You guys get to watch me do a promo.
One show specific, and then we're trying to bump up our.
Okay, so you want a show specific.
And then it's
All right.
awesome.
You guys get to watch me do promos. This is Paul Sutter, host of Space Radio here on WCBE 90.5 FM. And in Saturday's episode, I'm going to talk about germs. Gross, disgusting, biological germs. But they're in space, which makes it cool. That is Space Radio, 2 p.m. Saturday, WCBE 90.5 FM. And what should I do for the generic promo? The generic promo. I'm Paul Sutter, host of Space Radio here on WCBE 90.5 FM. And did you know that our universe is 92 billion light years across? That's right, that is billion with a B. Sagan himself would be proud. But you know what? All that matters is you and me. That's Saturdays at 2 p.m. Space Radio here on WCBE 90.5 FM. That was a good. I felt good one. What'd I do? I popped my piece. Sorry, Craig. That's right. You're gonna correct those waveforms. You're gonna scooch them down. And it was like it never even happened.
Right. Perfect. Perfecto.
Perfecto.
I was a homeowner for 20 years.
You were a homeowner for 20
My
years.
wife got in the way and I lost my house.
He's a renter and a runner. He is living on the run. Yeah. No, it is a lot less pressure to not out.
Month to month, so I can pick up.
Oh, you're wow. Because you live on the run.
You never know.
You know what I like better than saying perfecto is the Italian perfetto.
Perfecto.
2 T's. Perfetto.
Oh.
Perfetto. I like it better than perfecto. Perfetto. Because then I can do this. Perfetto.
Are you Italian?
No, but I lived in Italy for 2 years. Yeah. So, and that's all I said. I would walk up to them. I said, perfetto. And they're like, and I would like gesture, say, perfetto, perfetto. And they were like, get out of my country. I presume that's what they said, but it was Italian because I couldn't understand. All right. Space Cadets, thank you so much. Again, time went by. So Sunday, 8 p.m. Eastern, I will do a live where it's super chill. It's just Q&A, answering all your questions. So I'll see you Sunday at 8 p.m. No recordings, nothing like that. It's just pure live stream. So I'll see you then.